Hi, this is just a supplement to Roger's very well written answer. The only problem is with the text replies, it's often hard to use very clear notation just because we're so limited with what we can use. And so I figured I would make this quickly to have a bit clearer notation, but pretty much follow exactly what Roger said. Well done, Roger. Okay, quickly, the big idea behind the ratio test is if the size of your terms are getting smaller as you add more on, then you'll converge. And if your terms are getting larger, then you'll diverge. Obviously, there's some nuance to that, but that's the general idea. Okay, for our specific problem, it's easy to identify the nth terms and the an plus 1 terms. So what we should do is take the limit as n goes to infinity of the absolute value of their ratio. Okay. Doing that, taking this limit, we get something like this, which is pretty nasty. So instead of division, let's maybe multiply by a reciprocal and get to here. Okay. Now that we're here, we can cancel a bunch of stuff, namely everything down here with all but one of these. Now notice that this x minus 3 has no dependence on n, and so we can bring this outside of the limit. Careful, because we're taking the absolute values, we should take the absolute value of the x minus 3 even after we bring it out. Okay. As Roger went into detail about, both of these limits here, notice that this is exactly equal to what's left in here after bringing out this x minus 3. Both of these limits go to 1, and you can see this using L'Hopital's rule. And so therefore their product should go to 1 as the limit of n goes to infinity. Okay, so we get this absolute value of x minus 3 times 1 equals our limit L. But recall from our ratio test, we want to know when this is convergent. So the ratio test can help us decide when this is absolutely convergent. And it's absolutely convergent when L is less than 1. Okay? That means if the absolute value of x minus 3 is less than 1, whoa. Perhaps I should use freehand. Then it follows quickly that x should be between 2 and 4. Okay. The last thing to do is check these endpoints. And Roger goes into a bit of detail about which test to use in order to see if our series converges at 2 or at 4. Namely, the alternating series test when x is equal to 2, and the integral test when x is equal to 4. Okay, other than that, it's clear we have a center of 3 and a radius of 1. Okay, hopefully this was a little more helpful in using some cleaner notation to supplement Roger's answer, which, like I said, was great. The only thing you may have noticed is that I kept the x minus 3 as opposed to making a change to w. Everything else is exactly the same though. Okay, I hope this was helpful. Have a great evening.